Okay, so in this video we're going to add terms of an arithmetic progression. So for instance, if I wanted to find the sum of the first 20 terms of 2 plus 4 plus 6 plus ... Obviously I could go plus 8 plus 10 plus 12 plus and so I got the 20 terms, but that's pretty low tech, and what we're going to do is we're going to use a formula. I'm going to show you how the formula comes about, but at the end of the day, you just have to know the formula. Okay. So, excuse me. So in our AP, our first term is A, T1 is A, and then we've got A plus D, A plus 2D, and the last number, Tn, is A plus n minus 1D. So again, I'm going to generate the formula, but you don't have to know how to get this. So this last number is the general term, and it's the last number in the process. So to find the sum of the n terms, now previously we had T for term, now we use S for sum. So Sn just means the sum of n terms, whereas Tn equals the nth term. Okay? So if I was going to add those numbers up, I'd have A plus D plus A plus 2D plus ... plus the last number. But what we're going to do is, instead of using that, I'm just going to call the last number, I'm going to call that L. And the second last number will be L minus D, because you're going to add D to get to the last number, so it's going to be a subtraction. And then the third last term will be L minus D, etc. So at the moment, that's all you have to worry about for the time being. Okay. So this sequence, rather than having the last number as Tn equals A plus n minus 1D, the last number is L, the second last number is L minus D, and the third last number is L minus 2D plus etc, etc. So what I'm going to do is I'm going to line them up. So this last number is going to line up with the first number. And then this second number is going to line up with the second last number. And then third last number will line up with the third number, etc. And they'll all just keep lining up. And when you add those numbers together, you get A plus L. And when you add these numbers together, the D's cancel out, so you get A plus L. And when you add these numbers together, the two D's cancel out, and you get A plus L plus ... So the question is, how many A plus L's do we have? Okay, so I'll give you 20 seconds to think about it, and then come back. Well, you might have thought about it, that if I'm pairing them up, there must be half the number that we started with. Okay? So if I had 10 terms, there'd be 5 pairs. If I had 20 terms, there'd be 10 pairs. Okay, so here's where the formula comes in. So the sum of n numbers is n on 2, half the number of A plus L's, and that's a key formula. Okay? So learn that one, or you're going to have that in your cheat sheet, one or the other. But it's a really clever formula. To find the sum of numbers, you have n on 2, first plus last. But there's another formula, because we know that the last number is A plus n minus 1D, where the L is, I can put A plus n minus 1D, and then I've got A plus A is 2A, and then the n minus 1D just sits at the back. So we've got two formulas. So I've got n on 2 A plus L, and n on 2 2A plus n minus 1D. And I'll show you how to use those formulas. So for the original question, 246 plus ... up to 20 terms. So in method 1, we don't have the last term. So we use the long form of the formula. Okay, so n on 2 2A plus n minus 1D. N is 20 from the question, A is 2 from the question, the difference is 2 from the question. And so S of 20 equals n on 2 2A plus n minus 1 times D, and you just use your calculator and get 420. Okay, so that's pretty straightforward. But in method 2, you actually find the last term because we know that the term is A plus n minus 1D. So Tn equals A plus n minus 1D. So I find the last term, which is the 20th term. So in this sequence, 246, the last term is actually going to be 40. Okay, the 20th term will be 40. And so then we can use S of 20 equals n on 2, first plus last. And of course the answer must be the same. Okay? So, couple of variations. Okay, example 2. How many terms do we need, 5 plus 10 plus 15, to get a sum of 1,050? Now, we're not going to keep adding, etc., until we get to 1,050. We're going to use the formula. So we have our little legend on the side. A is 5 from the question, D is 5 from the question. We don't know the value of n, but we know that the sum is 1,050. Okay, so what we do is we set up the formula. So that S on n equals n on 2a plus n minus 1d, close. So 1,050 is the sum, n on 2 is n on 2, we don't know n, 2a plus n minus 1, so we don't know n, so we can't subtract, times d. Expand that out, simplify that, so 2 5s are 10. Now what I've done here is to get rid of the 2, I've doubled the other side, so 2100 is double 1050. And then I expand out that, I simplify the bracket to that, and then I expand it out, and I get this value. And you should recognise that as the start of a quadratic formula. But the trouble is, it has to equal 0. And so what I've done is I bring the 2100 across the other side. Now, you don't have to use factorising. You could use, one thing I've done is 5, 5 and 2100, I've divided everything by 5 to make the numbers a bit smaller. And at this stage here, I end up with this quadratic expression, n squared plus n minus 420 equals 0. Now, you've got to factorise it, or you can use the quadratic formula. I'm just going to factorise it. I'm looking for two numbers that multiply to 420 that have a difference of 1, and the numbers are 21 and 20. And so we end up with n plus 20 equals 0, which means that minus 21 is the answer. Or n minus 20 equals 0, which means that 20 is the answer. You can't have negative terms, so that answer's not right. And so this answer is the right one. So we need 20 terms. If you need practice on factorising quadratics, I can dig out a worksheet, but otherwise you need to factorise or use the quadratic formula. Okay, and from the electronic textbook, exercise 5C is where you're going. Okay, thanks, bye.